This is the title of my presentation, Big Data, HPC, AI, IoT, Cloud, and Folks, the core ingredients for bringing innovation to smart cities and infrastructure. So my central point is that technology is very important. Of course, I understand the other elements in bringing innovation to smart cities, uh, but I will focus on the technology side. Okay, so here is, before I go forward, here's a conceptual framework which we have developed recently together with some of our international partners, and we call it responsible urban innovation. And what you see here is that we have local government AI systems. We look at whether this technology is explainable, AI is explainable, ethical, trustworthy, frugal, and we look at cost, benefit, risk, and impact of that, and we look at the policy for the local governments, and of course from local government it connects to the national government, and it can be extended to internationally. And then we look at the community, what are their perceptions and expectations, and there is an interaction between these two elements, and basically this framework collectively looks at that. This is the outline of my talk. I have around 200 slides, and I know that I have 35 minutes, so I will go fast. So some of the slides, I will go very fast, but I could have focused on one, two things, but the intention here was to show that how innovation is driven by many small projects or large projects, and many of these projects are conducted by students. And these things come together because if we want to bring innovation to institutions, to country, then we need to empower the students, we need to empower individuals, and collectively, if we allow them autonomy, then they can create collectively a large impact in terms of innovation. And as we know, in order to innovate, we need many minds, and these need to be autonomous. So the outline of my talk would be that I will talk about a COVID-19 study as a motivation, what we have done in this work, and then I will go through the technologies which are fundamental in developing these works, and then I will talk about some applications which we have been working on. So I need to go fast, so please forgive me for skipping slides. So here is a work on COVID-19, and this is done by a PhD student, Abdulaziz here in Saudi Arabia. So what you see here is that there is a timeline, and this is detected automatically using Twitter data. And if you look at the bottom, you see that on 14th of March, we see COVID-19 start period here in Saudi Arabia. Then we start getting instructions about staying home, and then we start listening about prevention. There is some loan issues because now industry or offices are closed, so therefore people are finding difficult to pay their mortgages, for example, or run their daily things. So there is something connected to loan, and then there is hospital treatment because hospitals are not working in their full efficiency. On top of that, a lot of COVID-19 patients are coming. Therefore, there is issue about hospital treatment, particularly about blood donations, and then quarantine starts. Government start quarantine, and then we see that mobility has gone down. The curfew is imposed. Cleaning services are being used to clean the roads and other infrastructure. Government announces some salary incentives to help the private industry cope with the problems due to COVID-19 and closure of economic activities. Quarantine ends on this date around, so these are the dates I forgot to mention. So roughly mid of April, hospital treatment ends, so things get better because government start making people aware about the problems. And then COVID-19 ends, for example, around early June, and there are daily prayers issues in Saudi Arabia that they had banned them from going to the mosques. And then we have back to normal around early June. So these all timeline was detected automatically by Twitter data. And behind that, there were a lot of technologies. So this is the same picture, but I have made it in white background just in case color background doesn't come very well. Covariance between different keywords, different concerns. Again, I will not go in detail because the purpose is to show that what kind of things can be done. And here, this is the timeline, as you can see, from February to June. So our data was from February to June in this particular study. And what we see here is that we used LDA, unsupervised learning method, to detect some government concerns and government measures and public concerns. And here what you see is, for example, COVID-19 cases, applications, quarantine, daily prayers, stay home loan, cleaning services, hospital treatment, prevention. So all these were detected automatically, and this is a plot which is not very visible, but you can see the peak. For example, this peak I think is stay home, and then this yellow color back to normal this side, and this, for example, this light blue color for 5 daily prayers. So you can detect these events automatically. And then we divided these concerns into macro concerns, for example, daily matters, and these are the public concerns which are part of this macro concern. And then we plotted them and tried to look at them, that what is happening with these concerns or government measures separately, so we can look into it. And we also did some spatio-temporal visualization to see where these things are happening. What is the relative activity compared to different cities? So this is Saudi Arabia map. And what you see here is that there is Jeddah and Makkah, which is second largest city, Jeddah. And there is large activity here in relation to curfew. One of the reasons could be that Makkah is one of the holiest city for all the Muslims, and also in Saudi Arabia. So there is large activity here of discussions, because people are concerned about not being able to go to the Makkah city. And this is COVID-19 cases reported, and you can see here that you have different size of circles which show the intensity of activities, and there are some more bigger circles here compared to the previous slide. And what you see is that this is Riyadh, this is Jeddah, so Riyadh is the capital. So you see large activities happening here. Again, my purpose is not to go in detail, so I will now try to go fast. So how do we do this? So this is this particular thing, we call it Iktishaf, which is a tool. And what we do, we collect data using MongoDB, JSON. We do data pre-processing. So there are different things here which we do, and then we do measures and concerns detection. And then we extract spatio-temporal information from social media. And then in the validation module, we try to validate the events using external news and other media, and from internally from Twitter. We try to find automatically if there are tweets which are supporting whatever events were found. So here's some algorithm. Again, I'm not going to go through it. And here we have plotted the time, the execution time for these experiments. So what you see here is that if we use 24 cores, then we need 164 hours, which is more than 6 days. And then as we start increasing the cores to 168, then the time start going down to 24 hours. So we ran around 30 to 40 times the experiments, and if we would have run on the same 24 nodes, it's not even one core, it is 24 cores, then we would have needed, for 30 experiments, we would have needed 6 multiplied by 30, so more than 6 months. And by using more course and parallelizing it, we were able to bring this to 1 day, so 30 to 40 experiments done in 30 to 40 days. So this is a big saving. And then by doing these experiments many times, we were able to tweak the algorithm, finding number of iterations for unsupervised learning for LDA, which will give us good enough results, but we don't need to use all the iterations. So we saw that, for example, this one with 5 number of iterations, we are able to run the same experiment in 3 hours. So if we do the same experiment 30 times, then it basically takes us 90 hours, which is like 4 days. So we are able to bring down that computational requirement because we run them many times, we try to tweak the algorithm and so on. So this establishes the importance of technologies in enabling us to run things faster, and therefore we are able to find more insight into what we are trying to do faster, and therefore it helps us to innovate. And as we know that innovation is not just about the ideas and things, the timeline is very important as well. Many times delays can stop the innovation because the technology or the environment is moving very fast. So smart city, so I will go through now some of the concepts and technologies very quickly. So smart city can be defined as smart. This is now not that new, but I would still like to make the point that smart cities are not just about technology, but we need investment in human and social capital, and we need to bring the traditional and modern infrastructure together, and we need to fuel sustainable economic development and a higher quality of life in order to attract people with a wise management of natural resources, because planet is becoming very important through participatory action and engagement. So here participatory action is very, very important. You need to bring people together in order to bring innovation and to bring more ideas and so on. So smart city is about human and social capital and working together, and technology these days is playing a very important role, but the main concern should not be technology, rather the people. Okay, so here's the definition of smart infrastructure. I will not go through these definition, and I will go to the next technology. So one thing I can say is that smart cities can be identified along 6 main axes. This is well known work done by some people. So smart people, governance, mobility, economy, environment, and living. And then there are, around these 6 dimensions, there are things, for example, for smart people, there has to be affinity to lifelong learning, social and ethnic plurality. These things are very important. And smart governance, participation and decision making is very important. In mobility, sustainable, innovative, and safe transport is very important. Smart economy, entrepreneurship is very important. Competitiveness is very important. Smart environment, attractivity of natural condition is very important. Sustainable resource management is very important. Smart living, quality of life is important. So for example, health condition and social cohesion. So another way of looking at smart cities is systems view, which was originally presented by MIT, that a smart city comprises complex systems of systems. So these systems work together. So another way of looking at it is that we have reached to a ubiquitous converged infrastructure. We have many technologies and they have converged, and ubiquity of these devices, these technologies is increasing, and therefore we are able to control the cities through their microsystems or through their subsystems, and we are able to optimize the whole city. So here this smart cities driver, this show that we have reached a stage in the development of infrastructure. So technologies have reached that stage, and an approach to inclusive and sustainable cities. So social sustainability and environmental sustainability has become very important, and strategy for creating a competitive environment, economic sustainability has become very important, and competitiveness helps people to work harder, people to work smarter and work together, and that helps a country to grow, and internationally it helps the international community to grow. So here's some background about sustainability, which I'm not going to cover, but you can look into it. So we can look at the societies. We are moving from industrial economy to knowledge economy to digital economy to intelligent economy to smart economy. So here, basically, we moved towards digital first, and then we started looking at intelligence rather than just ICT, and then now we are looking at sustainability. So we are becoming smarter. So technologies, HPC, so the practice of aggregating computing power in a way that delivers much higher performance. So we bring multiple computers together and make things work in parallel and make things work faster. The importance of HPC is evident in this statement by Eric Isaacs, who is the director of Argonne National Laboratory. And what he said, the US cannot afford to take a backseat in computer technology to the Chinese or to anyone else. The nation that leads the world in HPC will have an enormous competitive advantage in every sector, including national defense, medicine, energy, environment, finance, manufacturing, and product development. So almost everything we need HPC to create a difference. And this statement was issued in a time when US was leading in high performance computing for several decades, and then China built its supercomputer, which was faster than any other supercomputers in the world. And it was stated at that time. And since then, things have changed. China is becoming better, but then other players have come as well. So here's a ranking of the top 10 systems in the world. And what we see is that the top supercomputer is Fugaku from Japan, and it is much faster than any other computer in the world. So the next fastest is Summit, which is in US, and you can see the teraflops of 442 and 148. So it is 3 times faster. Then we have different computers, many of them in US, and then in China, this one was one of their computer, which became the #1. And then you can see another one from China, and then Germany, Italy, United States, and even Saudi Arabia is now #10 according to this international ranking. This computer is bought recently. Before that, there was another computer, Shaheen, which was #7 when it entered the competition. So in Saudi Arabia, we are very committed. The government is very committed to build this capacity. And you can see here that Saudi Arabia is on #7 from this rating. These things change every year, 2 times a year, because the new supercomputers comes and the ranking keep changing. But US, Japan have been dominating this space, and now China has entered. So Hpc Market and Return, it is according to an IDC study. If you invest $1, then it can create $52 in return, and $551 in revenue. So it is an important technology to invest a country in, and it can build the capacity and innovate in the country. So I'm not going to go through this HPC. So big data, I think people know these days, and I will go to a figure to say. So big data can be defined by 4 characteristics. We call them V characteristics: volume, velocity, variety, veracity. So data is at rest, but huge amount of data. Data is fast because it's coming very fast. For example, from YouTube, from sensors in industry, and so on. There is variety in data. There are many kinds of data, structure, and so on. And there is veracity in data. Data is okay. I hope that it's okay, because I thought that I thought that it was disconnected. Are you able to hear me? Anyone can say yes? Hello?
Yes, sir, you were completely audible.
Okay.
Yes.
Okay, sorry.
Yes, sir, you are audible.
Okay, thank you very much. I need to go there now quickly. Okay, so I was talking about big data. So veracity, so data is in doubt because the data which comes to us, it might be missing data and there might be wrong data. So these 4 challenges are very important, and data value chain, that as the collectively data, its value goes higher, but individual items of data over time value goes lower. And then here there are different kind of analysis, interactive to exploratory, and their time requirement from milliseconds to hours. And here it shows that in every 60 seconds how much data we are generating. So you can see a number of sources, so Google searches, YouTube, and so on. I think this is well known. People know about this. Okay, so HPC and big data are coming together, and there are many analogies, many similarities in the work, but these were two different communities, and they are coming together. I'm going to skip things because I'm running out of time. So computational intelligence has become very important, as we know, and AI is part of it, and these three areas are converging now. AI is coming together, and we are talking about HPDA, high performance data analysis. IDC used this term, and that we need HPC resources for AI and big data, and that we do a lot of simulation and analysis, and we have data of all kinds, so we bring them together and we do high performance data analysis. Now, Internet of Things are becoming important because they allow us to sense our environment. So I'm not going to talk about it, but there are slides about, it's the market and definitions and everything, and different sectors which are important. Then connected mobility is very important. Now we are living in a different time because of COVID, that we move less. But before that, connected mobility was very important. And of course, we will go back to normal times, although there will be no more normal time per se like before. I think we will be doing more and more things online. But still, there will be a lot of mobility, and therefore connected mobility is very important. There's something called vehicular ad hoc networks or self-managing network. This is very important, in a city. So autonomous connected mobility, very important. And an example is this bus, which is a collaboration between IBM and another startup. And this is autonomously driven. And IBM Watson is used to communicate, interact with the passengers. And then, some news, for example, in Dubai, they announced some time ago that 25% of all transportation will be smart and autonomous, driverless by 2030. These autonomous buses running in Helsinki. So here, because we do a lot of HPC, so here a depiction that how an autonomous car works. You can see that through LiDAR, they are able to see that who is standing, what is happening around it. And again, this is, mapping technologies which are helping to develop high quality, very detailed maps. Behind them, there is NVIDIA is one of the players. They have developed this card which is fully autonomous driving. Intel is also working on technology for autonomous cars. Google car, famous, for a long time, many years. It has been driven many thousand miles, many hundreds of thousands of miles. And BMW concept cars. So all these players are coming now, and if you search, you will find many examples of futuristic cars being built, autonomous cars. Some study about how much trust people have in driverless cars, and Internet of Vehicles, how much savings you can bring. All these are acting as drivers for bringing autonomous cars. So broader area of autonomous cars is autonomous systems, and you can broaden that concept from autonomous vehicles to drones, for example, to autonomous ships, robots, androids, and then socio-technical system. For example, our devices are becoming more and more autonomous, and so on. And social and connected autonomous vehicles, personalized healthcare systems. So, for example, here we are going towards personalized healthcare in the sense that we are collecting data from our environment as well as on our DNA level, and we are creating personalized interventions in terms of pharma, lifestyle, and nutrition, rather than before where the medicine was for a population. And then other technologies, 3D and immersive environments. So virtual reality is becoming very important already. It was already very important, but now with COVID-19, there is more emphasis on it. We can do, for example, we can develop models of virtual models of dresses or of houses, and people can go inside the houses virtually, or they can wear the dress and see how it looks like to them. So the concept of digital twin and other things are coming together. So this is an important area. Then cloud computing is very important because it allows us to incrementally use resources on demand, and you know, we don't have to invest things. And the reference architecture for cloud computing, then mobile cloud computing, because a lot of data is generated from mobiles. So how do you bring the mobile and cloud computing together? And then edge and fog is coming in between to bridge the gap, because clouds are farther from the edge for mobile, from, you know, for example, smart agriculture, industry, and so on. Taking the data from here to the cloud takes time and create high latency. So we can bring fog computing inside to bridge the gap and do things faster. So a lot of work is happening in this space. Some economic factors of economic drivers of fog computing and edge computing. So data management is important. You know, we need to look at spatiotemporal management of data, data as a service, data fusion. Basically, we are moving towards the vision of Mark Wager, which he presented in '91, that technologies that weave themselves into the fabric of everyday life until they are indistinguishable from it. So in a way, we have reached to some level of this vision. People are more and more on their mobile phone, and we are getting ill as well. I think we need to think carefully what we are doing. And I'm not saying that whatever is happening is good, but what I'm saying is that technology is moving to a time where it is disappearing gradually in our environment, and we do things, many things autonomously, and these technologies are doing many things autonomously. So ongoing research, I will cover a few things. So this is done by another of our students related to healthcare and using Twitter data. So we collected information about the top diseases in Saudi Arabia. So we found that the top one is diabetes with 31%, and then dermal hypertension 27%, and then dermal disease 20%, and then heart related disease almost 16%, for example, cancer 2.63%, and some others. And then after cleaning the data and after removing some unrelevant data, because many keywords can be same from different areas. So for example, in Arabic, sugar means the same thing as the disease, and also a date kind is also same name as the disease, diabetes. So therefore, this kind of things, these are well known in data analysis. So we were able to clean up those data and found a more refined outcome, and divided them by cities and try to study that how different cities are behaving in terms of diseases. Again, I'm not going to talk about what diseases there are. Awareness and how much awareness activities different cities are doing, and nationally how much awareness activity is doing, and how much people are talking about afflicted diseases. So there's this shows the relationship between them. And this is the architecture of this, we call them Seha in Arabic, means health. And this is the analysis of machine learning algorithm, that how well they perform. Another work we did on 6th generation networks together with Internet of Everything. So here is a depiction. So this is another PhD student here. We are working on this. So what we see is that 6G work has begun. I mean, at this time we are in conceptualization phase, but the main difference between 5G, because we know that 5G hasn't been realized fully, we haven't seen it everywhere. But in 5G, the focus was on the speed of data. But in 6G, the focus is on AI, that how do you provide AI to applications, and as well as how do you use AI to improve the quality of the network. So because of the time, I can't talk about this. All these works are published, and I'm happy to point to them. Anyone is interested, and you can find the details there. So we did the study with some focused case studies. So one of the study was on a newly built airport in Jeddah. We looked at different kind of sensors and how much traffic they will generate and how we can provide them support. And these are basically different modules in those studies. Again, as I said, that I will go faster. We looked at, for example, their energy requirement, their delays, their network requirements, and the cost saving, which will happen if we use fog and edge computing. There's another smart city called KEC in Saudi Arabia, and we modeled a district there as well and try to look at different sensing requirements and what kind of traffic and everything and cost savings we will get. And this is the detail. Again, these are published, so you will be able to see them. Okay. So the concept of this work was to provide distributed AI as a service. And as I said, that you can look at. Okay, there's another work here. We call it Iktishaf. This is traffic event detection. And this is the architecture of that. This is related to the COVID-19 work, but here we are using supervised learning. So here it shows that what kind of activities are happening on different events. So we were able to detect different events. For example, there was a fire. Without any prior knowledge, we were able to detect them, weather condition, weather events, social events, and different events like road damage, traffic conditions, accidents, and so on. So here the depiction of the these events, where they are happening and how much is their intensity. So these colors show what these different events are there. Size of the circle, so how much is the activity, and then the location shows where they are happening in Saudi Arabia. Okay, then another work with Taha Muhammad we have done using reinforcement learning on creating a framework, UB PreSec, which means ubiquitous, previously enhanced and security enhanced quality of service enabling framework. And this was done with 5G. And we use deep reinforcement learning to optimize the network quality, and the fog and edge nodes were there as well. And here is some, and we used a well-known application, which is sparse matrices, which are fundamental to many applications, including deep learning. Another work with Dr. Furqan Alam from your university, Amity University, and he kindly put me in touch with you. That's how I'm giving this talk. So I thank him, and I believe we all need to thank him to create these opportunities. Dr. Alam has done this work where he has brought connected vehicles and autonomous vehicles together, and they are able to share their environment with each other and optimize the decision about their environment. So, for example, in extreme sunlight condition, we can have a mirage, and we might think that there is some water or something there. Similarly, in shaded region, gray region, we might not be able to see certain things. So by looking at cars which are in different places, we can avoid these situations. So this is very important work, and falls under AI and data fusion. So other works we are doing on disaster management, where we are able to use vehicle ad hoc networks and information dissemination to optimize the traffic flow. Here it shows green, here it shows more black-red, which means congested. And we detected some events in London. For example, one of the events we detected was related to economic activities and job hiring, and we located it that it was in Canary Wharf, which is the economic district in London. So this shows the power of AI and social media, and a lot of our work is to do with social media as well. Some more works about detecting events, I will not go through them. Some work we did in the using the US road network data, the whole US road network data. We use a large number of cores because we have a supercomputer here. So we are able to go large, and we did different works based on this US network data to understand the connectivity, to understand that if we want to move from point A to B and there are a large number of queries coming in the same time, how would we parallelize those queries, and how much time it will take. This work is done again by Dr. Alam, and I'm not going to go through it, but this is related to the earlier work which I mentioned. A lot of our work is about using other traffic data, such as sensors data coming from the ground, the inductive sensors which are put under the roads, and we collected large data from 11 years data from US, because a lot of these data are openly available in the Western countries. So we use that one to optimize, to develop some forecasting. And we also did some work on traffic incident detection using the US data. And this is disaster management work as well, using GPUs and in-memory computing. And we did another work on London Metro to optimize the network flow in terms of metro and other modes of transportation. Again, all this work is published. Another line of our work is on DNA profiling, which can be used to find, for example, paternity, maternity, the father, the mother, and it can be found, for example, it can be used to find criminals, for example, from DNAs. So we have developed some work here which uses 10 unknowns, means there's a mixture in which there are unknowns. And typically the work done in internationally is 3 to 5 unknowns, but we were able to go up to 10 unknowns, and we were able to bring time from 5.8 days to 2.7 hours. This 5.8 days was interpolated because no one has done this amount of unknowns, because the problem is exponential, and with every unknown, the problem goes many times more in terms of computational complexity. We use more than 3,000 cores to do this work. We have done some work on smart pain management, some work on car-free cities, and we have done some work on traffic, that how much traffic it will generate if we run different applications like healthcare or learning application. UT-Learn, this work is also done by Dr. Alam from your university. I will not go in detail. I'm finishing. I'm just touching on things so that you are aware of the work. So UB Health, another work where we looked at healthcare related demand and to optimize the network to improve the security. Work done by an MSc student, and this is published in good journal as well, Q1 journal, and this is available. So another line of work, which is major activities on sparse linear algebra, and this is considered one of the 7 dwarfs by Stanford, Berkeley, and you can see here this is sparse matrices, and these are different applications. So it falls with many applications, and as I said, that one of them is deep learning and machine learning. So for example, climate and weather, stellar atmosphere, so many applications it is central to. So for example, for CFD is very important application in designing aerodynamics, planes, cars, and so on, structures. So I will not go through it, but there are a number of works we are doing here to improve the speed of these computations on GPUs, on Intel MIC, on CPUs, on distributed nodes, and so on. So I will not go through it. I will go towards finishing this. So we are doing a lot of activity in terms of creating conferences to spread these research, as well as to bring people together and innovate. So this is some of the work on smart cities and society, some work on smart infrastructure. So HPC Center, KU, our drivers are the level of expertise and infrastructure in HPC will determine the competitiveness of a nation and its global standing leadership. So our mission statement, we provide different services, particularly not only related to providing hardware access, but parallelizing the code, speeding up the code, and so on. This is information about what kind of nodes are available. The name of the computer is Aziz, and we have 3 kind of architectures. So Xeon Phi, which is Intel MIC architecture, NVIDIA GPUs and CPUs, Intel Xeon. So these are the architecture. I will not go through it, and some information about what kind of people are using it. The high performance computing, you will see that most of the people are using it, and social studies people are now turning towards that as well. So the conclusions, Smart cities provide next generation engineering approaches. Smart cities aim to exploit intellectual and social capital. Smart cities are driven by several independent trends. These include a pressing need for environmental sustainability and people's increasing demand for personalization. We need to develop smart infrastructure, and a key challenge in the realization of this infrastructure, which is fundamental to our cities and society, is to create an ecosystem of digital infrastructure that are able to work together and enable dynamic real-time interaction. So this is an important thing we need to achieve. And in order to do innovation, we need to bring technologies together and make it available to people so that they are able to use these technologies without much effort. Acknowledgement of my collaborators, students, and there are many more, and I should add them, sit down and add them, references, and thank you very much.